Hi there, folks. Today we're looking at measuring angles, and we're going to do this in a couple different ways. We're going to do it from the perspective of literally using a tool to measure things, but then also kind of comparing measurements and that kind of stuff. We'll get into the angle addition postulate, and so just different ways that we can figure out the measurement of certain angles, and then how we classify some of that. All right. So first things first, an angle is just basically when we have a shape that's formed by two rays that share the same endpoint. And so if we look at the example here, AB is a ray, AC is a ray, and they each have the same endpoint at A, which forms this angle, okay? And there's a couple ways that we label angles, all right? So the first way is using the points. It's that same format that we've been doing for everything. We just need a new symbol. Like we used points to label a line and we used a little line symbol above it. Well, now for an angle, we just put a little angle in front of it and then we label it. And the order here is important. You just have to make sure that whatever order you list this in is the order that the angle can be drawn in. For example, you could say B, A, C. That would be acceptable. Or you could say C, A, B. You could not say A, B, C because, again, if you traced it in that order, from A to B to C, it wouldn't give you the angle we're talking about. That would give you this angle instead. Okay, so think about tracing the angle. You should list it in the same way that you would trace it. Okay. The other way that we could list this particular angle is if we have an angle sitting all by itself like this one, we can just label it with the vertice. We could say, hey, this is angle A. All right, is another way to do that. You're probably asking the question, well, why in the world do we need that first method if we can use just angle A? Well, if we have more than one angle that starts at A, how do we know which angle we're talking about? And we'll see that coming up in a little bit. So that's why we need the separate protocols. And again, in terms of universal use, that first one of using the points is typically one that we'll use a lot. The last one, and this is probably my personal favorite, and anytime I have a question that has angles, if they're not labeled with numbers, I go through and label all the angles with numbers, because if there's a little number in there, like a 1, I can just say, hey, this is angle 1. Done. Okay? So that's the different ways that we label these things. Again, it should be very logical. It should make sense. You could probably guess at how to label the angle later, and you'd be able to guess it right. Okay? We use the angle symbol, and we label the angle that we have. In terms of this thing, interior versus exterior of the angle, the interior is usually the part that we're pretty concerned with. The interior is the stuff that's in between the two rays. It's typically that shorter, that smaller segment. So that would be the stuff in here. That's the interior of the angle, okay? Versus the exterior of the angle. The exterior of the angle, oh, sorry, I meant to use a different color there. The exterior of the angle is the stuff on the outside. Okay, and we'll look at the relationship between those things, but the exterior of the angle is all the stuff out here. Okay, and so the idea is looking at the relationship between those two things. We'll start to think of that in terms of a circle. If you went the whole way around, the angles would add up to 360 degrees, and that's something we'll look at a little bit later in the course. Okay, but just be aware of that. For now, we're more concerned with the interior of the angle, and when we label these things, we're almost always talking about the interior of the angle. All right, so if I say angle BAC, I'm talking about the interior, not the exterior. Okay, so just be aware of that. For example, let's just do some naming. It says, give two other names for angle 1. All right, so angle 1, I could label this in different ways. I could say, hey, that's angle. I could use the point system and just say that's angle JMK. That would be an acceptable name for this thing. And again, think about tracing it. Start at J to M to K. I've drawn the angle. Or I could use something like angle KMJ. All right. Again, if I start at K, draw to M, draw to J, I've drawn that angle. The second question here is, why can't I use the label of angle M? All right. So why would angle M not be an acceptable name for angle 1? And the answer is, well, look at where M is. At M, I have more than one angle. In fact, I have 3 angles that start at M. I've got this guy, angle 1. I've got this guy, angle 2. And I also have this big angle, JML. Okay, so there are 3 different angles that could be angle M. And so it's not specific enough, all right? So the reason we can't use M is because angle M could represent more than one angle. Okay, so you just got to make sure that it's specific enough that I know what angle we're talking about. All right, saying angle M doesn't narrow it down enough. Okay, and again, that's why we have multiple ways of doing this. The protractor postulate, this is not a real important one. This is kind of like the ruler postulate where I'm going to read it, and then you're never going to see this again ever in your lives, not even in this course. Okay, so just follow along with me here. But basically, given ray OB and point A on one side of ray OB, every ray OA can be paired with one-to-one, can be paired one-to-one with a real number from 1 to 180. And just like the ruler postulate was basically saying, hey, we can measure things, we can fit these to a measurement and measure the distance. And here the ruler postulate is basically saying, hey, we can fit these things to a measurement system so that I can measure it, but now we measure it in terms of angle, in terms of degree, okay? So that's how we measure the angles. For example, if I look at this guy, just showing you how to use a protractor, that's all we really care about right here. But if I take something like this, so this is a protractor, and what we do when we use a protractor, you notice right here, see that center, we have that little line. Some protractors have a little hole there, but we want to put that right on the vertice of the angle, all right? And so when we do that, we put that on the vertice, and then we line up the bottom here with one of these rays. Well, now I can look at where A is, and it looks like it's about, and again, look at the inside measurements this time because I'm measuring in that direction. See, I want to start at 0. If I use the outside, notice there's a 180 there and it's counting down. So I want to start at the 0 and I'm counting up, and it looks like 110 degrees, okay? So that's how we use a protractor. Again, we just line up that one ray with 0, and then we go from there, okay? So again, this one, this was, and I only have one angle here, so I could say angle O. And since it's a measurement, I'm going to say the measure of angle O equals 110 degrees. In terms of the angle types, we classify these in different ways, and you've probably seen these before or heard of them before, but we're going to use this a lot in geometry. All right, so acute angles are the ones that are smaller than 90 degrees. They're between 0 and 90. A 90-degree angle is that special one. We call it a right angle, and I'm sure you've heard of right triangles before, or you've talked about perpendicular lines before in algebra, and those are 90-degree angles. They're right angles. Obtuse is when we go bigger than that. So if we're above 90 but less than the 180, it's obtuse, all right? And then a straight angle is the one that is 180. That's probably the one you haven't seen before, all right? Is that 180 being called a straight angle? Basically, it's a line, all right? So we can consider a line an angle. It's just a special kind of angle. It's a straight angle, okay? And now let's use the protractor the other way. We're going to use this to actually draw, okay, some of these things. So if I wanted to draw an angle, again, start with a ray. So use a straight edge to draw a ray. I'm using the line on my paper as my straight edge right now. But what we want to do is we want to put a point as our vertice, and then what we can do is we can slide this thing over. So then I take my protractor, I can move it over here, and again, I line that up on the vertice. And then all I do is I use my pen or pencil to make a mark here. So if I wanted a 35-degree angle, I just look at where 35 degrees is. So like come in here, here's 30, here's 40, halfway in between is this mark right here. So I put a mark right there, and now I'll be able to draw that angle, okay? And so I slide my protractor out of the way. Say, excuse me here, little fella. And I draw a line, and I want to use a straight edge here. Don't freehand this thing, okay? I'm going to use a straight edge, so I start on the vertice, and I connect it to that point using a straight edge, okay? Or a ruler of some kind. And see, now I have a 35-degree angle. Then it asks me to draw a 90-degree angle. So again, I could do the same thing. I'm going to start from the same spot. I bring my protractor back over. I line it up. Then I say, okay, let me do a 90-degree angle. So for a 90-degree angle, again, I'm measuring it using the inside track. So it's right here, and I put a little mark right where 90 degrees is. Oh man, I had a really tiny mark that time. I scoop my protractor off to the side. I get my straight edge out. And there we go, 90-degree angle. Okay, and that's known as a right angle. All right, and the symbol for a right angle, if we wanted to label this so that everybody knows it's a right angle, I can just put that little box in there. Remember, that little box in the corner means it's a right angle, and we'll see that a lot. Symbols become really important as we go through some of this stuff. We see them a lot in geometry. Okay, and so now I line it up on the vertex. I come over here and say, okay, let's get 145 degrees. Again, I'm using that inside track. Here's 140, 150. And then I can use these little tick marks on the outside, but I'm looking at this instead of 40 is 140. Instead of this 30, it's 150. So 145 is right in between there. I can put that point. And then again, I scoot it off to the side. And now I can use my line tool. Done and done. Okay? And then the last one, the 180 degrees, I really don't need my protractor for this one, do I? I mean, I could bring my... Sorry about that. I could bring my protractor back over, but it's really unnecessary. If I know that 180 degrees is a straight angle, meaning that it's a line, I could literally just draw a line, okay? If I did bring my protractor back over, hopefully you can see where that 180 is. It's down here, okay? So again, I'm not even going to put the mark down. Let me scoot it off to the side and say, okay, where's my line tool? From here, it's straight over. Done and done, okay? And again, just drawing those things, it seems silly to sit here and use a protractor to draw these things, but you'll see protractors embedded on certain things. Like one of the things I use all the time when I'm working on my house is a miter saw, or a compound miter saw, all right? Some people call it a chop saw. It has basically a protractor built into it so that you can measure angles, okay? So that you can make cuts to the wood that are at a certain angle. There are certain things that you'll kind of see this same concept built into certain tools that you'll use throughout your lives, okay? And then again, thinking about the labels of these angles, the 35 is acute. This one is 90 is a right angle. 145 is obtuse. And 180 is a straight angle. So just to be able to draw those angles and understand the difference. Okay. The next question here is, what is the measurement of the angle formed by the second and fourth ray? And I erased them, but I can redraw those. So the second and fourth ray, so let me redraw those. The second ray was this one right here. Oh, sorry, this one right here, because the first one is the first ray that I've drawn. So that was this ray. There's the first ray. Here's the second ray. The fourth ray was this 145-degree angle. So basically, I'm trying to figure out what is the measurement from this guy to this guy. I want to know what this measurement is in between these two angles. Okay, and so there's a couple ways I could do this. I could bring my protractor over and turn it sideways, all right, and take a measurement. So if I did that, if I grabbed this, and mine's a little bit cumbersome to use because of the computer, all right? But I could turn my protractor sideways, line that guy up with this line, so that bottom line, okay? And then I could try to take the measurement and say, it looks like to be about kind of maybe a 110 again, all right? So I could measure it that way, or I could think about this for a second and say, wait a minute. I know the measurement of each of these angles here. I know that this guy, the first angle that I drew, was a 35-degree angle. And I know this whole thing is a 145-degree angle. So couldn't I just use a little bit of subtraction to figure out what this guy in between here is? And notice the measurement that I thought I came up with was 110. If I subtract those, I get a 110. And see, the concept there, all right, is that we're talking about the angle addition postulate, which we'll see in a moment. okay? And so just trying to look at that and say, okay, that's pretty easy to figure out even without me telling the angle addition postulate, okay? But we can use a protractor to measure those things. Obviously, doing it without the protractor is faster, okay? So congruent angles, we've talked about congruent segments and that kind of stuff. Congruent angles, same thing. They're angles that have the same measurement. Just like congruent segments were segments that had the same length, the same measurement. Congruent angles are ones with the same measurement. And we label that with lines. We have the same number of little dashes through them. With these, we'll put the same number of arcs. So if you see one arc on each of these, it means that those are congruent. If you see two arcs through each of these, it means that those are congruent. And if I had another angle here that only had one arc through it, it means that one doesn't match the other two. Okay, so if they have the same number of arcs, that's how we visually show that these are congruent. Okay, so again, the idea here is that the measure of angle A, if that equals the measure of angle B, then that means that these two angles are congruent. So now angle A is congruent to angle B. And once again, there's that subtle difference. When the values are the same, we say they're equal, and measurements are values, they're numbers, okay? But when the shapes are the same, we say they're congruent, okay? So here the measurements are equal, the shapes are congruent, okay? The actual physical drawing of the angles are the same, okay? All right, let's talk about that angle addition postulate. We already have it kind of formulated in our minds. You could probably guess at what it is. I probably don't even need to tell you. But if point B, and this is kind of a mess when you read it, all right? If point B is in the interior of angle AOC, then the measure of AOB plus the measure of angle BOC equals the measure of angle AOC. Whew, that is a mouthful, okay? But all it's saying is, hey, if a big angle is split into little angles, the little angles add up to the big angle, all right? The little piece plus the little piece equals the whole thing. It's the same as our segment addition postulate, but now with angles, all right? And we kind of used that already when we were talking about that measurement of that weird angle in between some of the rays. And we were able to measure it with a protractor, but it's a lot faster if we can do it using a little bit of math, okay? And so again, it's just saying, hey, this angle here plus this angle here equals this whole angle, all right? Little angle plus little angle equals the whole angle. That's it, all right? For example, if I look at something like this guy, it says if the measure of RQT is the entire angle, is 155, find the measurement of the smaller angles here, all right? And again, the idea here is the little angles added together equals the whole thing. So in other words, if this first angle, and I'll write it out, so the measure of RQS plus the measure of angle TQS should equal the measure of the whole thing, which is RQT. And then from here, it's just substituting in. We know that RQS is labeled right here as a 4x minus 20. We know that the measure of TQS is listed as a 3x plus 14. And then we know the measure of the whole thing was given to us. That's the 155. Okay? And so now we can simplify. We can solve for x. I combine some like terms here. That's a 7x and a minus 6. I'm going to go ahead and add that 6 to each side. Oh, that is a terrible looking 7. I can do better. I believe in me. All right? I believe in my skills. So over here I get a 161. And now I'm going to divide each side by 7. And I get x equals a 23. Okay? But again, that doesn't even answer the question. See, in algebra, we're used to this. X equals this. I'm done. I did it. No. This asks for the measurements here. I got to plug these back in. Okay? So I have to plug that 23 back in. If I plug it in for that first angle, I do 4 times 23 and then minus the 20. That gives me a 72. So that was the first angle. Let's see. The measure of angle, that was RQS that I just plugged it into. Equals 72, and that's degrees. Make sure you have that kind of unit listed. And now the other angle, there's two ways that I can do this, and I would recommend doing each of these ways just to check your work. We can plug it in there and do 3 times the 23 and then plus the 14. It gives us 83 degrees. But a quick way to check this is, aren't they supposed to add up to 155? So add them together. Do they add to 155? Yeah. So I probably did this right. And if they don't add to 155, then I definitely did it wrong. Okay? These are really easy to check once you're done. Okay? If I look at the next one, same kind of thing. It says if angle DEF is a straight angle, find the measure of DEC and the measure of CEF. So once again, the angle addition postulate just says, hey, the two smaller things add up to the whole thing. So the measure of angle DEC plus the measure of angle CEF equals the measurement of the whole thing, the measure of angle DEF. Okay, the two pieces add up to the whole thing. That's it. All right, and now it's just substituted in. We know that DEC is listed as an 11x minus 12. We know that CEF is listed as a 2x plus 10. And we know that DEF is a straight angle, which means we know its measurement to be 180 degrees. And now we can easily solve for x. I combine some like terms. That's a 13x minus 2 equals 180. And now I'm going to add that 2 to each side, so I get 13x equals the 182. And now I'm going to divide each side by the 13. So I get x equals a 14. But once again, I'm not done. I have to plug it back in. So if I plug that 14 into the first angle there, the FEC, I get a measurement, measure of angle. I mean, I labeled it as CEF before, so I guess I'll label it as CEF. If you label it as FEC, it doesn't matter. It's the same thing. Okay, so that gives me a 38-degree angle. And now once again, to find this other measurement, to find the measure of angle DEC, I can plug it in, which I think is a good idea. I think it's a good idea to plug this guy in. After you plug it in, then go ahead and do the subtract, the addition to see if it adds up to that 180 like it's supposed to, okay? So I got a 142 when I plug that guy in. And now, quick check, add them together. Do they equal 180? Yes, I probably did it right, okay? So again, measuring angles using a protractor, understanding the different categories of angles, acute, right, obtuse, and straight angles, and then the angle addition postulate. The little pieces add up to the whole thing.